Yes. So I was telling you what are direction cosines. So direction cosines are nothing but the cosines of the angle which this line OP is making with the x, y, and z axis respectively. So cos alpha,
Yes, sir.
cos beta, cos gamma are the direction cosines, where what are alpha, beta, gamma? Alpha, beta, gamma are the angles that the OP vector makes respectively with x, y, and z axis. Right. So if you look at this figure, and let's try to mark the angles here. Suppose OP is making this alpha angle with the x-axis. It is making this beta angle with the y-axis, and it is making this gamma angle with the z-axis. So
Yes,
the
sir.
cos of alpha, cos of beta, and cos of gamma, they are known as direction cosines. And they are represented by a small letter L, small letter M, and small letter N.
Yes, sir.
Now let's see what will those be. Suppose I draw a perpendicular from here to the x-axis. Now you are getting a triangle here, right angle
Yes,
triangle,
sir.
right? Suppose this point is x, suppose this point is y, and suppose you draw a perpendicular to the z-axis as well, and suppose this point is z, right? So what will be cos of alpha from this triangle? The first triangle OXP. Use trigonometry and tell me what will be cos of alpha.
Sir, cos alpha will be sir x upon r.
X upon R. Yes, OX upon OP. Very good.
Yes, sir.
OX upon OP. And OX is nothing but the x coordinate. The distance from the YZ plane is x. X is distance from the YZ plane.
Yes, sir.
In 3 dimensions, it becomes distance from the planes. YZ plane, this becomes distance from the XZ plane, and Z becomes the distance from the XY plane.
Yes, sir.
So OX upon OP will give you X upon R. And similarly, what will be cos beta?
Sir, cos beta will be
Y
y
upon
upon
R.
r. Yes, sir.
Y upon R. And similarly, cos gamma will be Z upon R.
Z upon r. Yes, sir.
Now, if you try to find out, this is small l, this is small m, this is small n. Now, if you try to find out L square plus M square plus N square, what will you get?
Sir,
X square upon R square?
sir, x square plus y square plus z square upon r square.
Very good. which is equals to x square plus y square plus z square upon r square.
Yes, sir.
And x square plus y square plus z square is nothing but r square only.
Yes, sir.
It gets cancelled and the answer is 1. So that means the square of direction cosines added together gives you 1. The sum of the squares of the direction cosines is 1.
Yes, sir.
This is a very important rule. L square m square plus n square is equals to 1. This is all about direction cosines. Now this is done. Now this also gives you the idea of components of a vector.
Yes, sir.
Components of a vector. Look at the same diagram and let's draw the axis again. Suppose this is x-axis, this is y-axis, and this is z-axis. And this is a vector OP whose coordinates are x, y, and z. So essentially, this vector has been broken down into
3 parts.
three parts, three components, which are perpendicular to each other, right? So
Yes,
there
sir.
is one component which is x, other component y, other component z, and x is actually a vector which is directed along x-axis, right? Y is a vector which is directed along y-axis, and z is a vector which is directed along z-axis. If we add all three, we will get this OP vector or the R vector. So in other
Yes, sir.
words, we can write R vector as the sum of x, y, and z.
Yes, sir.
But how do we represent x as a vector? We need to introduce unit vectors
Unit
in each direction.
vectors.
I, j, and k.
Yes, sir.
What is I, j, and k? I, j, and
Sir,
shall mean
yes, sir.
they are unit
Sir,
vectors in the direction of x,
yes,
y, and
sir.
z axis respectively.
Yes, sir.
Right? And unit vectors are represented as I and then a cap symbol on the top of it.
Yes, sir.
So they are three unit vectors in the direction of x, y, and z axis. Now unit vector has magnitude 1, and if I multiply that by a scalar x, I will get xi vector
Yes, sir.
or xi cap. This is known as a cap. It is also read as a cap.
Yes, sir.
So xi cap is the x component of this vector. Similarly, y into j cap is the j component of this vector or the y component of this vector, and z into k cap is the z component or the
That
k
component.
component of this vector. And when you add them, you will get
Yes.
the r vector.
Yes, sir.